Welcome back to GateX AIML. So today we'll understand the concept of central limit theorem. So central limit theorem is actually the heart of your statistical analysis. So let's begin and try to understand what exactly it means and why we are learning this. Okay. Before going to that, why this normality matters? What is normality means? Normality means converting any distribution to your normal distribution. Why? Why should I convert any data? The central limit theorem, I'll give you an overview. What is central limit theorem? Central limit theorem is a tool which helps us to model any data to the normal distribution. So what is that you are learning? In the second chapter, I told you this is the population. From this, you take some sample and then you calculate some mean, okay, variance of the sample, and then you say from this you estimate the population mean, okay, or population variance, something like this. Now, the population follows some distribution. We don't know the unknown distribution. So it follows some distribution. It may follow some exponential. It may follow some. It may follow normal distribution. It may follow Poisson distribution. Whatever it may be. So what the central limit theorem says is whatever may be the data follows, whatever may be the distribution, we can model it to the normal distribution. Why? Why should I model it to normal distribution? Because the following reasons. Mathematical convenience. The normal is symmetric. You solve so many problems you understood. The symmetric curve. Symmetric means it's very clean. You can easily calculate the probabilities. And also it is defined by perfect average, that is mu and sigma, standard deviation. Now, probabilities, always you calculated CDF, that tables are already available. So for your new distribution, you need not sit and calculate all these values. So if you convert your distribution, that is your data, to your model as normal distribution, then easily you can use all the existing values. Then inference becomes possible. What it means? The tools like confidence intervals. What is confidence intervals? We'll see next. But when I model this x bar, okay, plus or minus some error is equal to my population estimate of the mean, then confidence, what confidence? Okay, you are saying this matches this. That is, we'll see in the confidence interval. So all the confidence intervals require central limit theorem. That is, central limit theorem is based on normal distribution only. Okay, hypothesis testing. The main agenda is hypothesis testing. That is, this is that your hypothesis. The hypothesis means some inference you are going to make. Whether your inference is correct or wrong, that is the hypothesis test. The inference you make is a hypothesis. So, for example, say that the average salary of employees in India is say 30,000 rupees. That is your statement. Whether the statement is true or false is the test of the hypothesis. That is your hypothesis you have made. Average salary is this much. Okay, so there we require the normality. Then regression to rely on normality. That is the basic of your machine learning algorithms. Predictability of average. In real world, we are usually interested when you solve some problems in the real world, when you estimate some data and estimate the parameters of some data. So basically, you focus on averages. So when you focus on averages, so it is easily can easily calculate using the normal distribution. Error analysis. Okay, it's a bell-shaped curve, that is symmetric. So in many of the physics and engineering and finance problems, the random errors combine into bell-shaped curve. So it's now easy to find out the errors. Then this is the universal approximation. So universal boss. Any messy distribution can be approximated by normal distribution. That is why normal distribution is important. Now we'll come to central limit theorem. Central limit theorem helps us to map or reduce any distribution to normal distribution. This works regardless of original distribution. Now we'll try to understand what is the central limit theorem. Let x1, x2 up to xn are IID. IID means independent and identically distributed random variables. In the next slide, I'll come to that. with mean mu and standard deviation sigma. Then for large n is the sample size, the x bar, that is sample mean is normally distributed with these parameters. This is the mean and this is the standard deviation. This is what is the definition of central limit theorem. If you are given some n independent and identically distributed random variables, then with your mean mu and standard deviation sigma, then that distribution, that whatever the data you get in this distribution can be mapped to normal distribution with these parameters. That is what it means. Large n usually means n is greater than or equal to 30. Again, we'll come to this for non-normal data. If the data is non-normal, that doesn't follow normal distribution. If you get n greater than or equal to 30 sample points, 30 or more sample points, then we can convert it into or map it to or reduce it to normal distribution. So let us try to understand one by one what are these terminologies. First, what is this IID? Independent and identically distributed. So as the name suggests, first the independent. Independent random variables means what? That's what you have been learning. So two variables are independent if the probability will not change based on the one variable. So x1, x2 are said to be independent if x1 has no effect on x2 and x2 has no effect on x1. For example, rolling two dice, rolling a 6 on one die does not change the probability of rolling 6 on the other die. If I roll two dices, so the probability of dice for getting 6, okay, and probability of getting 6 on the other die are independent. That is the meaning of independence. Independent random variables. X1 is independent, x2 is independent. Similarly, when I say x1 to n, so all sample points x1, x2 up to xn are independent random variables. So that is first condition. Next, identically distributed. That means what? They come from the same distribution. So they are not coming from the different distribution. So for example, that what it means, all variables come from the same probability distribution. Say the x1, x2, xn all comes from the same distribution. That it means it is identically distributed. Why? When it comes from the same distribution, all will share the same mu and standard deviation. That is what it means. For example, if all mangoes have weight sampled from same distribution, each weight comes from the same mango weight distribution. See, what it means is there are different types of mangoes in the world. Okay, all the mangoes of different types, type 1, type 2, type 3 is there. All they are not of the same size, right? The mangoes, for example, type 1, the mangoes will be small. In the type 2, the mangoes may be large. So these are different distributions. Okay, in each of the types, okay, if I take some 100 mangoes, if I take the average weight, then all the mangoes I should take from the type 1. Like say that I have type 1 mangoes, type 2 mangoes. If I want to find the average weight for this sample of this type 1 mangoes and average weight, okay, I want to find mu2, mu1. Okay, so first I will take some n value for this and then I calculate x bar. See, mu1 is for entire population of type 1. So from type 1 I will take n samples. Here I will take say n1 or say x1. Here I will say n2 samples and then I will calculate the sample mean x2. Now what it means here in this independent here means what? When I take this type 1, there are say x11, x12, these are the random variables. So these each mangoes, each random variable represent a mango for that sake, to take that example. Are independent. This mango is independent of this mango, but they are in the same distribution. That is what it means, identically distributed. I cannot take a mango from here and I can take a mango from here and then I calculate the average. That is not correct. What finally IID means, independent, each random variable in that distribution is independent and identically distributed, means it is coming from the all the random variables are coming from the same distribution. That means IID. This conditions has to be satisfied for the central limit theorem. Independent and identically distributed. Okay. Next, why normal distribution appears? Even if the original population is not normal, averaging may independent samples smooths out randomness. So that is the proven thing. For n greater than or equal to 30, it has been statistically proven that the sample mean tends to follow normal distribution. Okay. For smaller n, that is n less than 30, you may require t distribution. Okay, that is use of t distribution. You have calculated the t statistic, z score, t score, everything, right? So that we will be using here. Now, why n is greater than or equal to 30? For non-normal populations, n equal to 30 is considered sufficient for the approximation to normality. Smaller n may require the using the t distribution. As I said, it is statistically proven. Now, how we will see the distribution of the sample mean, central limit theorem. So we will give it as sample mean x bar can be converted. I have data. I have to calculate this x bar for this data. I don't know what distribution it follows. So I am trying to map it to normal distribution with mu and sigma by square root of n. That's it. That is what it means. This is the central limit theorem. Now, there are two things. When will you apply Z score? When will you apply T score? Z score is applied only when population standard deviation is known. That is, population variance is known. So again, the same idea. I have a population. Okay. I get a sample from this. I want to estimate the mu value. That is mean of the population I want to estimate using the sample mean, because I cannot get the entire population value. So now how good is this? This is what you are saying. So now if I want to calculate this and then test, okay, for that I have to use the z test or z test. Only when I can apply z test, only when I know this value. For the population, I know the variance of the population sigma square, not s square. Sigma square is known, then I can apply the z test or z test. Getting it? Okay. Now when will you apply t score? So there are two things. One is population standard deviation is unknown. That means if I don't know this sigma, then I will go for the t test. T test is applied when the variance of the population sigma square is unknown. Also, you will apply when n is less than 30. N is less than 30. This already was seen. The only thing here is what? The test is applied for the sample mean. So from your t score formula, you replace this random variable x with the mean. See, what is z you have written? Z equal to x minus mu by sigma. What you have written. So instead of this, you make it x bar. That is for your testing for the mean, not the x value, and divided by square root of n. Okay, because this is sigma is known, variance is known, population. That's what I'm using this. By square root of n. Next, I will explain it. Here, the variance is unknown. That is the reason why I go for here. This is sample standard deviation, S square variance. Sample variance, from that I will take. Okay. That is the only difference. So in the question you have to identify this. This is very important. If the population variance is known, you apply the test. And the population variance is not given, you apply t test. Okay. Okay. One more thing, why this is square root of n. Okay. The square root of n, the reason here is, see, when n tends to infinity, we get any distribution. If you increase the sample size, we tend, the CLT says that when n tends to infinity, any distribution tends to or approaches normal distribution. Okay. So for that reason, If you take square root of n, the value, the sigma value will be reduced, right? Will be reduced. So we will get more number of the symmetric of the distribution will be more. If you draw this diagram with n and square root of n, you will understand. So the symmetry will be better. The skewness will be less. Skewness means what? The second chapter understood. This is the what I want. So if I take square root of n something symmetric, I will get like this. If I take n, sometimes little bit skewed, I will get like this. So that is the reason I use square root of n. That is the meaning. Okay. We'll take simple examples. So these problems you may be asked directly like this, but why we are calculating here is just the same thing we already done here, but when it is for sample mean, to divide by this, and then you have to identify whether it's t-test or t-test in the problem. And then in the next central, after that confidence intervals, we'll be using this again. We will be applying some intervals for this values of z or t. So let us take an example. The average weight of mango is 250 grams. The standard deviation of 40 grams. If a sample of 64 mangoes is taken, what is the probability that their average weight is less than 245 grams? Okay, see, average weight of mango is 250 grams. So the given population mean, and then they are saying sigma equal to 40, standard deviation of the population. Sample size is 64, x bar is 245. They are just asking how good is this estimate. So probability of the weight less than 245 grams. 245, that is x bar minus mu divided by this value. You will get it as -1. So using the z value, you calculate 0.1587. Probability that the mango weight is, average weight is less than 245 grams. Okay, this is the probability. What exactly you are doing here? 250 is the entire population 250. If I say I calculate it as 245, the mean, with what probability it will be less than 245? That's what I'm saying. So from this you can definitely infer something, right? There is some, whether it's a good estimate or not a good estimate. Okay, anyhow, they are given the values here, but in the real statistical analysis, these values are not known. So in the confidence interval, we'll understand it. What is that you're finding? Similarly, if IQ of student has unknown population standard deviation, unknown means you have to apply t-test. A sample of 25 students has an IQ mean of 105. So sample mean x bar is 105 and sample standard deviation is 10. N equal to 25 students. So population mean is 108. What is the probability that the true mean is less than 108? This is what we are estimating now. I am saying that what is the probability that it is less than 108, exact, the mu. So you apply t-test, x bar minus mu. This is what is I am saying, whether it's a good estimate or not. 108 is a good estimate or not. Divided by 10 by square root of 25. This will give you minus 1.5 with degrees of freedom 24, that is n minus 1 degrees of freedom. So P of t less than minus 0.07. Probability is approximately 0.07. Okay, what it means, I am saying I have calculated x bar is 105. Okay, now this is what I want to find. Okay, now let us assume mu is equal to 108. Let us assume some value. Okay, whether it's a good estimate or not, that is what I am trying to find. So now what I will do, I will calculate the sample mean. I have taken 25 student sample and then I am saying the sample what I got is mean is 105. Okay, now with what probability this is less than this? Okay, so if I take this 105 and then calculate the probability, I'll get 0.07. That means what? mean is less than 108 is 0.07. That means what? It's a very low value. Probability that it is less than 108 is 0.07. That means probability that it is more than 108 is 0.93. That is 93% chances that the value that I estimate, okay, this is 93%. There are chances that it is more than 108. So my 105 estimate is a good estimate or not. Okay, that you have to choose using confidence intervals. In the next chapter, I will say. Okay, that is what you are doing. It's all about the entire statistics. So if the variance is unknown, population variance is unknown, you apply t-test. It is known, you apply z-test. So like this, you are going to estimate your mean value based on z-test or t-test in the real world also. Okay. Similarly, if you want to find the range, there is a single value. Okay, I have to estimate the mean, right? Population mean. I'm now trying in a range. So I got 120. Whether this 120 is a good estimate, that means whether it lies between this or this. So it says it lies between that 2 points with this probability. The same thing. You do not worry, you already know how to calculate this. Okay, Z1, Z2 calculate, and then I'll calculate what is the probability that the distribution is what I'm saying between lies here. Okay. So this is saying 0.76, that is 76%, around 76%. Your actual, your whatever you're estimating, no, for the population lies between this with 76% chances. That is what it means. So we are estimating. Okay. Hope you got this. In the next video, once I explain the confidence intervals, it will be more clear actually how you are estimating it. Okay. Thank you for watching. Please like, subscribe, and share.